we are going to learn how to find the analytic function if its real part is given to us. We can also determine this analytic function with the help of the Minley-Thompson method, which we will discuss in the next content. So, I'm going to find this analytic function with the help of the CR equations, right? So, let's start. Let fz be analytic function. So, writing fz to be as u plus iota v, and from here real part of fz is u, and the real part of fz is given to us, that is real part is e to the power 2x into x cos of 2y minus y sine of 2y. So let's write this real part as u. So this is e to the power 2x into x cos of 2y minus y sine of 2y, right? So from u we can determine curly u over curly x and curly u over curly y, which are used in the CR equations. So finding from u curly u over curly x and curly u over curly y. So differentiating this u with respect to x, we get first function and then the differentiation of the second one. So we have to differentiate with respect to x. So this is cos of 2y minus this is 0. Then plus second function and the differentiation of the first. So this is by the product rule, x cos of 2y minus y sine of 2y, and the differentiation of first function is multiplying e to the power 2x into 2. So taking e to the power 2x common from both the terms, so this is cos of 2y plus, and 2 is also multiplied with this second term, so this is 2x cos of 2y minus 2y sine of 2y. Let's mark this as 1. And then finding curly u over curly y. So differentiating u with respect to y, we get e to the power 2x. This is negative x sine of 2y multiplied with 2 minus sine of 2y minus y cos of 2y. 2 is also multiplied with this. So taking this negative sign outside, we get negative of e to the power 2x, 2x sine of 2y plus sine of 2y plus 2y cos of 2y. Marking this as 2. Now since fz is analytic, so u and v must satisfy Cauchy-Riemann equations. Very good. So you can use any of these two equations first, but I'm using this first equation. So it is curly v over curly y is equal to curly u over curly x, and we have already found curly u over curly x. So writing the value for the curly u over curly x from here, from 1, so this is e to the power 2x, 2x cos of 2y minus 2y sine of 2y plus cos of 2y. So to get the value of v, we have to integrate this with respect to y, taking x as constant, right? So integrating this with respect to y and taking x as constant. So integrating this with respect to y, we get left hand side to be as v, right? So this is v is equal to, okay, so this is constant e to the power 2x, right? So writing this as e to the power 2x as it is. And now integrating this with respect to y, we get 2x will be written as it is. So integration of cos of 2y is sine of 2y over 2. And integration of y sine of 2y, this will be, we have to integrate this by parts, and then from here we get sine of 2y over 2. So when you integrate this completely, you will get x sine of 2y plus y cos of 2y plus phi x, where phi x is a constant, right? So where phi x is constant and it is an arbitrary function of x. Now from the second equation, we are having curly v over curly x is equal to negative of curly u over curly y. Just writing this negative sign to the other side, we get curly v over curly x is equal to negative of curly u over curly y. And we have already found out curly u over curly y, right? So differentiating v with respect to x, we know what is v from here. So let's differentiate this with respect to x. So this will give us first function, differentiation of the second one, that is sine of 2y, this is 0, plus second function x sine of 2y plus y cos of 2y into differentiation of this first function, that is 2e the power 2x, plus differentiation of this is phi dash x, because we are differentiating with respect to x, so a differentiation of phi x is phi dash x. So this is equal to negative of curly u over curly y from 2. Now curly u over curly y is in negative, which is negative of e the power 2x. That will become positive. Because of this negative sign, this will become positive e the power 2x, and then 2x sine 2y plus sine of 2y plus 2y cos of 2y. From here, if you notice that this sine of 2y is cancelled out with this sine of 2y with e the power 2x. So this is cancelled out with this one, and here I am having 2 times e the power 2x into x sine of 2y. And I am having from here 2 times e the power 2x x sine of 2y. So this term is also cancelled out. And similarly, I am having 2 times y cos of 2y. And I am also having here 2 times y cos of 2y. So this term is also cancelled out with this term. So remaining, I am having only phi dash x, right? So this is phi dash x is equal to 0. So therefore, phi dash x is equal to 0. So this implies phi of x is some constant, right? So C is an arbitrary constant. And writing the value of phi x equal to C in V. I'm having V is equal to e the power 2x into x sine of 2y plus y cos of 2y plus phi x. Just put the value of phi x over here and get your V. So V is equal to e the power 2x, x sine of 2y plus y cos of 2y plus that constant phi x, that is C. So I'm having this V, and also we know that u is given to us. So writing fz is equal to u plus iota v and putting the values of u and v over here. So we get our analytic function finally. E the power 2x into x cos of 2y minus y sine of 2y plus iota times this v, that is e the power 2x. Let me write like this. Iota e the power 2x into x sine of 2y plus y cos of 2y plus iota c. So now taking e the power 2x common. So e the power 2x, and from here I'm having cos of 2y, here also I'm having cos of 2y. So taking cos of 2y also common in the first term. So I get from here x, and from here I get iota y, right? So this is x plus iota y with common cos of 2y, right? Okay. From here I get negative sine of 2y I'm having here, and sine of 2y I'm having here. So can I write this negative as iota square? So writing this as iota square and taking sine of 2y common, I get plus iota square into y plus iota x, and writing sine of 2y. iota x and writing sine of 2y. And then plus iota c, let me write this as c dash. Is it fine? Okay. Next step, e the power 2x. Okay, what is x plus iota y? This is z. Z is equal to x plus iota y. So writing x plus iota y as z. So this is z cos of 2y plus taking iota common, I get x plus iota y, that is again z. So this is iota z sine of 2y plus c dash. And now taking z common from here, we get this is to be equal to z e the power 2x into this is cos of 2y plus iota sine of 2y plus c dash. So this is equal to z e the power 2x, and by Euler formula this is equal to e the power iota 2y plus c dash, which is further equal to z into e the power 2 times x plus iota y plus c dash, that is equal to z into e the power 2 times writing x plus iota y as z plus c dash. So finally we get our analytic function in terms of z. So f of z is equal to z e the power 2z plus c dash, that is the constant. So in the next content, we will determine the analytic function with the help of the Milne-Thomson method, which is very easier to use, right? Okay, thank you. God bless.